Okay, this is AP grade 10, and the last couple of days we were busy with the trinomial, and tonight we just want to look at the perfect square, which is also a trinomial, but a special type of trinomial. Now when we do a square, so say for instance we have x plus 3 squared. Now when we did products, this should have been done under products also. So then we know we square the first one, and then we take the first times the second times 2, which will give me 6x, and then we take the square of the last one, which then will be plus 9. So if we work in reverse, if we just do everything in reverse, then obviously the square root here must go there, because we squared it from there to there. And the square root there must go there, because we squared it from there to there. And then we said the middle one is this one times that one times 2. So if we divide this one by 2, we must get then also the middle one. So here we have a check. We have that the square root of this one should give me that one, and this one over 2 should give me that one. So if I get that right, I know I've got a perfect square. So for instance, what I mean by that is, if we look now at x squared, say plus 12x plus 36. Okay, now if I do the square root, let me just get us another color. If I do the square root here, okay, that's going to give me 6. Let me just write 6 here. And if I divide that by 2, this is also going to give me 6. Okay, now I know, hey, I think this is now a square. But now I must just check my final thing. And that is, can I get the square root here? Yes, I can. So now I know this is definitely a square. The x comes in here. The plus remains the same. And that answer that is the same, the 6 and the 6, comes in here. So that is just a perfect square. This is important for us when we do... remember, you are doing in grade 10, we are doing the basics of a lot of stuff we're going to do in grade 11 and 12. So that's really very important. So, so often we do things here that you're going to use in school. But for AP, actually, we do it because we're going to need it in other work. And in this case, we're going to need it in the complex numbers. Alright, so this is really important for us. Now in the book in the right, and this is my book that I wrote for the university, the new one. I just took some stuff out of that and put it in for you. So the explanations is on the right hand side here, thoroughly done actually. Alright, let's just go to the next page. Just see here. Okay. So that's that one that we just did. I think we can just look at maybe that one there. So again, I go and I say to myself, right. So I go and I say to myself, can I find the square root here? Yes, it's going to give me 9y. Can I find the half here? It's going to give me 18. Okay, now this is a bit different. So I must just be careful. Remember, the reason is because this one is now giving me 2. So remember, the middle one is that one times 2, and that agrees, because 2 times 18 is going to give me the 9 here. I mean, that's the 2 times the 9 is 18, times the 2 is giving me 36, and half 36 is also 18. So this times this is giving me 18, and this half is 18. If I just go back to the previous page, just to explain this just a little bit again. Remember here we had 1 in front. We had 1 in front. That's why we could just say the square root there is 3, and half this one is also 3. Half this one is actually 3. If we divide by 2, we get 3. But you see, the 1 times the square root there. So the square root here, which is the square root of 1, the square root of 1, and the square root of 9. This gives 1, this gives 3. 1 times 3 is 3, and half that is 3. So it still agrees. It's just that the next one is a bit more complicated. So let me just go back here again, and let us just do this again together. Okay. So the square root of the 4 is 2. The square root of the 81 is 9. The 2 times the 9 gives me my 18, you see. And the half the 36 is also giving me my 18. So now I know this is definitely a perfect square. So it will be then the square root of the first one, which is then 2x. The sign remains the same, the second one there. So that sign there is the one that's coming in here. The square root of the last one, which is the 9, and the y, and that is a perfect square. Okay, so the perfect square is important for us. Often I get questions, but sir, this is just a trinomial, so if I factorize the trinomial, I should get the answer. Yes, and then you are perfectly correct, that is true. But remember, there's a time factor. So time management in mathematics is also very, very important. So the guy that can see here, hey, this is a perfect square, is going to take 1 minute or so, and the other one that's going to find the factors might take 3 or 4 minutes, and that is actually the difference. But I agree that it is a trinomial, so if you can factorize a trinomial, you should get to this answer. So it's not such a pity if you cannot see that it is a perfect square. But honestly, again, I want to say it has to do with time management. So if we can just look at this 4.7 number 1a here, just remember that you now, once you've done all the factors or all these, that you can have combinations. So remember that we start with a common factor first. So here we take a common factor out first, and then we have a trinomial. Now I can test. Square root is 4 is 2. Square root is 1. 2 times 1 is 2. Double 2 is 4. So this is a perfect square because the 1 times the 2 times the 2 is giving me my 4. Okay, and then we can apply that this is a perfect square. So the common factor is out. Square root comes in here. Square root comes in here. That times 2 gives me the middle one. That's how I check. It is explained here. So the square root there, the square root there. That one times 2 must give the middle one. Therefore, I can be quick in my perfect square. So I'm just sort of focused to look at the first and the third. That's why I try to get you over to the AC method, because if you are used to focus on the A and the C values, you can be so quick, and then you see, wait, that's a 4, I can get the square root. That's a 1, I can get the square root. So what is the square root of 4? It's 2. What's the square root of 1? It's 1. 2 times 1 is 1, and double that is 4. It does give me the middle one, and you know immediately that is a perfect square. People that's not focusing on the AC will not even see it. You will see in class. And that the people that does not do the AC method, remember, it doesn't matter when you factorize trinomials which method you do. That's not that it doesn't matter. But I'm just saying that if you are focused on the AC method, it helps to see a lot quicker. I've got a perfect square here. That is what I'm trying to say here. Okay, so perfect squares. That's how we will do them. Just be very careful. I just need to show you this last thing here, which I put in for this reason. And that is, if we look now at this example B over here, okay, now we see, there's definitely a common factor there, which is the 5, which I need to take out, okay, because I can take out a 5 everywhere, which I did. And now I sit with this trinomial. Now I'm focused on the AC. I see the square root there is 1, the square root there, I can get the square root, I can get the square root. This is 1, this is 3, so it's 1 and 3. But if I multiply it by 2, remember that's a 3. If I multiply that by 2, I do not get the middle one. So this is not a perfect square, the brackets here, and just a normal trinomial that should be factorized further. Okay, so I just wanted to show you that it's not always, if you can find the square root and you can find the square root, that it will be a perfect square. Be very careful. Mathematics, can sometimes bite us in the butt there if we don't realize we need to go through the rules. We need to apply the rules to make 100% sure that we are okay. Okay, so that is about the perfect square then. So just be careful that it's not every time a perfect square. Now, if we look at the difference of squares, okay, and I always say, listen to the words. Listen to the words. It's the difference of two squares. Okay, so it's the difference of two squares. Okay, so like 16x squared minus 9. Okay, so there's my difference. And this is a square because I can find the square root. And this is a square because I can find the square root. So this is the difference of two squares. This is very, very important. I'm saying again, you are doing the basics of stuff to come, especially the complex numbers. So then we can factorize. I know you've done this in grade 9 also, but we need to revise it very quickly. So that square root comes in here, in the first position, and in the first position. And then that square root comes in there, in the second position, and the second position. And then one must have a plus, and one must have a minus. It doesn't matter which way around. This could be minus, and that could be plus. That doesn't matter as long as one has a plus and one has a minus. And remember now, it is the difference of two squares. Okay, so if we have a binomial, a two-term with a difference, you must already think, hey, I've got here a two-term with a minus between them. Isn't this maybe the difference of squares? And then we need to start with a common factor first. So we do our common factor, 2d, and then we look at the brackets here. Yes, I can find the square root. Yes, I can find the square root. It is a minus, so this is the difference of two squares. Therefore, the square root in the first position, square root in the second position, one with a plus, one with a minus, and I'm done. So that is the difference of squares. We're going to go more quickly over this because this is done thoroughly actually in grade 9 also, as I say, but this is important for us. So the difference of squares we need, as I say, for especially for the complex numbers. Now when we have the sum of squares, if we have the sum of squares, that's a different story. Okay, that means we have a square plus a square. And then in the real number system or the rational number system, we cannot factorize the sum of two squares. You will see later that we can factorize them as complex numbers. This is important to look out for. But for normal school, in the real numbers or in the real number system, we cannot factorize the sum of two squares. So be very careful when people ask you, say for instance, to factorize 4a squared, say plus 9b squared. Okay, don't get into trouble and try and factorize them. You must see this is the sum of two squares, and that cannot be factorized in the real number system. So we say this is actually a prime number, né? So this is a prime number, cannot factorize it. A prime binomial if you want, because it's a two term. So you can say this is a prime binomial. So meaning there it is, prime polynomial or binomial or polynomial, doesn't matter. Polynomial just means many terms. Bi means two terms, but the point is that this is prime. You cannot factorize it. So please, this is very, very important. Okay, now the last things that I want to look at tonight is the sum and the difference of cubes. And this, I think, is one of the factors that is done by students or they answered the worst. Alright, so this is really important. So again, the wording tells us it's the sum of two cubes. So it's a cube plus a cube. Or the difference of two cubes is the cube minus a cube. And then here's the rules how you find the factors for that. So let us just do that example. So if we have x3 plus 8, so I've got a two term with a plus. I know I cannot have sum of squares, so now I have to ask myself, could this be the sum of cubes? Yes, it is, because I can get the cube root here, it's x, and I can get the cube root there, it is 2. Now, when you factorize the sum of cubes or the difference of cubes, but let's now stick to the sum, we've got a small bracket and a big bracket. Okay, sorry, I'm not going to be able to fit that in there. Let me just move it here, just to show that big one there. Then the cube root comes in here, which is x, because x times x times x. The same sign here. Then the 8 is 2 times 2 times 2, so it's 2 here. Now we go to the big bracket. Now be careful here. Now we square this first one, so that's going to be x squared. Then we change the sign, very, very important. And then we take first times second, which is 2x. Now be careful, it's not first times second times 2. It's just first times second. And then we do the square of the last one, which will then be 4. Okay, now that will now be a prime trinomial. In other words, you will not be able to factorize this trinomial. So don't even try. Because that should have been a 4. Okay, so you cannot factorize that bigger one. It is a prime polynomial. It doesn't have factors in the real numbers or in the rational numbers. It doesn't have factors. So that's where you're going to stop. Be very, very careful, because people go on later on, they don't realize, they forget, they don't know their work, and they factorize this prime polynomial or trinomial and get into trouble. So let's say we have, we say we have 8x to the 3 minus 27y to the 3. Okay, so this is the difference of two terms. So I can think, is this the difference of squares? No, because I cannot get the square root. I cannot get the square root. Okay, so is it maybe the difference of cubes? Yes, because I can get the cube root. I can get the cube root. So then there must be a small bracket and a big bracket. The big bracket will be prime. So what comes in the first position here? The cube root. So 2 times 2 times 2 and x times x times x. The same sign. So then the cube root there. So 3 times 3 times 3 and y times y times y. Okay, so I'm done with the first bracket. Now this first one squared comes in here. We change the sign. Remember, I also said there the signs must be different there. That sign is the same there. This sign is the same there. This one and this one should change. And then I just take the first times the second. So it's going to give me 6xy. Not times 2. Just the first times the second. So it's just 6xy. And then plus the square of the last one. 9y squared. Sorry, that should be inside there now. And let me just try and fit it in here, but I think I'm a little bit on the edge here now. I'm not going to be able to get this in here. I'm just going to move it a little bit closer. Okay, so we said the sign must change. Then we take first times second, which is just 6xy. 6xy. And then we must have a plus. And this one squared, which is the 9y squared. And then we close the bracket. And this is a prime trinomial, meaning you cannot factorize it. Do not try to do that. You cannot factorize it. Okay, so if we can just look at these final two examples. So remember now, the question will be factorized, or factor each of the following, or factorize each of the following, or something like that. Now, be careful. Remember, now it's easy for us because we know we're busy with this topic. But remember, in an exam or a test or something like that, they're going to be all combined together and mixed. You know, trinomials, sum of squares, difference of squares, sum of cubes, difference of cubes, and combinations where you first have to do the common factor and then look and see. So you need to really understand it well so that you know what to do. So remember, you start with the common factor first, if there is a common factor, and then see what you have. Do you have a 2-term? Do you have a 3-term? Do you have a 4-term? 4 terms you have to group. Trinomials, we know now what we must do, or the perfect square. Don't forget your perfect square. And then if there's a 2-term, see if there's a plus or a minus. If there's a plus, it can only be the sum of 2 cubes. If there's a minus, it might be the difference of squares or the difference of cubes. So just be careful there. But in this case now, it's just 8x3 minus 27. There's a difference there. And that tells me that it can be the difference of cubes, or it can be the difference of squares, but I cannot find the square root there. I can find the cube root, 2 times 2, 2 times 2, 3 times 3 times 3. Therefore, I can factorize it. It's the cube root 2 and x, cube root 3, that one squared, change the sign. Remember, this sign and that sign should be the same. Square that one in the end, change the signs here, and just take that times that, not times 2, that times that. So it's 6x. So this is a prime trinomial, cannot go any further, so you stop there. Look at this one. It's the sum of 2 term with a sum. Well, it cannot be the sum of squares. So let's see if it's the sum of cubes. Can I get the cube root? Yes, 5 times 5 times 5. And remember, you can check that on your calculators. Ne? So 5 times 5 times 5, t times t times t, 4 times 4 times 4, z2 times z2 times z2. So put it in. Cube root, same sign. Square that one, change the sign. That one times that one. Just that one times that one, but with a different sign. Square this one, 16z4. So that the 2 and the 4 can give me my 6 back. The 1 and the 2 can give me my 3 back, t3 back. Okay, so this is prime, cannot go on, I'm done. So that is then the sum and the difference of cubes. I want to warn again, I think this is maybe the ones most people forget to look at and get caught out in exams and tests because they cannot factorize the cube root, or the difference of cubes or the sum of cubes, especially when we're going to do factoring rational expressions, where you have to factorize the top, factorize the bottom, cancel out the factors and so on. That's coming. So if you cannot factorize your numerator and factorize your denominator proper, then you're not going to get, and those questions are high in marks, but they're still coming. But the point is we must be very good in factors to handle rational expressions and rational functions later on. Okay, but for tonight, we're going to conclude this for tonight. So please make sure that up till here you are good in factoring all the different expressions.